Hi everyone, this is lesson 6.5, Triangle Proportionality Theorems. So today we're going to learn a few theorems that we can apply with similar triangles. So the first one is called the Triangle Proportionality Theorem. It states that if a line is parallel to one side of a triangle and intersects the other two sides in two distinct points, then it divides the two sides proportionally. So it divides the two sides proportionally. And we know that when we have proportional sides, we have similar triangles. So here, also remember to be consistent with your ratios. So are you comparing sides of triangles or parts of sides? So after we look at these examples, we'll figure out what that means. So first of all, you've got triangle EAC here, and you've got FB is running through it parallel to EC. Now, it doesn't say that F and B are midpoints. It's not that. It's not the mid-segment theorem or anything. It's just saying that it's parallel to the other side. So F may or may not be a midpoint of EA. Probably not. It's just at a random point. But it's in such a way, so if they're parallel, then so the ratio that F cuts A to E is also the same as B cuts CA. Okay, so then we've got, sorry about that. So then we've got similar triangles then. Okay, so if this whole side of the larger triangle, if that side is proportional to FA and AC is proportional to AB, then you have similar triangles because you also have this angle they share in the middle, and you have, corresponding angles because you have parallel lines, all that stuff. So let's take a look at these ratios that we have. So you've got AF over FE. So AF, why is it still showing the eraser? Okay, so AF to FE. So here we're comparing sides for ratio 1. So you're comparing, or sorry, not sides, I meant parts. Let me fix that. You're comparing the parts of the triangle, not the sides. Because FE isn't the side of any triangle, it's just a part of the larger triangle. So we would then compare it to the parts over here. So AF corresponds with AB, and then FB corresponds with BC. Okay, number 2, AB over BG. Let me erase it, pick a different color. So we are comparing AB and BG. So once again, you're comparing parts here. So if that's true, if we're comparing those parts, then we're going to compare it to the entire length. So whenever you involve the bottom part of the triangle, you're going to include the bottom part of the other triangle. So if you do BG, then you're going to do CD. Or whenever you include the parallel line, I guess. You want to include the parallel line for the other triangle, for the same side. So we'll do AC over CD. So I guess in that case, it would be the sides of the triangle. My apologies. So we're doing the sides of the triangle here. And then FB and EC. So think about that one. FB is this entire parallel line over EC, which is this entire parallel line. Okay, so what could we set that equal to? Well, there are a couple different options. We can say AF over AE. Or you could do the opposite side, AB over AC. So here you are doing a ratio of the sides. And then how about this would be the third one. So how about the fourth one? It says BC to FE. So here's BC. So that's just going to be part of the triangle to FE. Okay, so we're going to do the other part of this triangle. We could do AB to AF, kind of like number one. AB to AF. All right, let's look at a few examples. For number one, EC is parallel to AB. Find the value of x. So here, there are a couple different ways we can set up our equation, our proportion. One is to just do x over 16 equals 12 over 8. Okay, and then you can reduce and then cross multiply. So 12 over 8 would be 3 over 2. So this would be 2x equals 16 times 3, 1848. So x is 24. For number 2, it says Qn is parallel to LM. Find x. All right, so this is basically the same thing. So you could do x over 45 equals 20 over 25. Reduce and cross multiply. So this would be 4/5. So this would be 5x equals 180. So x is 36. All right, so here's the converse. It says if a line intersects two sides of a triangle to form proportional pieces, then the line is parallel to the third side. All right, so we'll look at examples of that. But here's a different theorem. If a ray bisects an angle of a triangle and it divides, so if it bisects the angle of a triangle, so this ray here, clearly it bisects because these two angles are congruent, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. So those two would be proportional with these two sides. So what is the opposite? What is the side opposite of the bisected angle? That would be DB. What is the correct proportion to set up? You could say it's DC to AD, and then equals BC to AB. Obviously, there are a few different ways that you could write that proportion, but that's one of the ways to write it. All right, so if we wanted to find x here, we would set it up as x over 9 equals 8 over 12. Now, another thing they did not say is that if you've got an angle bisector, then it's automatically also a segment bisector. This is not a segment bisector. Obviously, these two triangles are not congruent, but they are proportional. And it might not be drawn to scale either. So don't count on it always being drawn to scale for you. So 8 over 12 would be 2 over 3. So this would be 3x is 18, x is 6. For number 4, you could do a over 3 equals 6 over 4. So 4a is 18, a is 4.5. Okay, easy enough. Let's do a few more examples. All right, the corollary. I'll say that 5 times fast. A corollary means that it's an extension of your theorem. So you've got your theorem, and then your theorem also brings you to some other conclusions. So here's one of them. It states that if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. So you've got 3 parallel lines, and you've got, these are your transversals. So these parallel lines intersect your transversals proportionally. So AB to BC is going to be proportional to DE to EF. AC to DF, so the whole thing to this whole thing, you could say would be AB to DE. Could you have said BC to EF? Yes, that would have been fine. And then AB, this last one here, it says AC, the whole thing, to BC. Then you would state the whole thing over here, DF to EF. So DF to EF. All right. So here's a little example. So we see alternate interior angles are congruent. So we know that these lines are all parallel. And what are we trying to find? DE. So we're trying to find this guy right here. Well, we know that this is 32, and we know that that's 21 and 28. So let's let this be x. And you could do x over 21 equals 32 over 28. Now, just remember that you can write proportions differently. So you could have said x over 32 equals 21 over 28. It would give you the same answer. You see how it's just this number that's like flipped? That's going to give you the same answer because you're multiplying those two numbers anyways. All right, so simplify your fraction over here and reduce, and then you can cross multiply. So those both go into 4. So this would be 8 over 7. I feel like I'm doing something wrong. No, I'm okay. And then cross multiply. So 7x equals 21 times 8. I'm going to cheat on my calculator. Is 168. Divide 168 by 7. You get 24. 24 is the answer. Number 6, determine whether PQ is parallel to LM. So PQ and LM. Well, let's check to see if the sides are proportional. So let's do about 16 over 24. Is that going to be equal to 18 over 27? Well, there's nothing to solve here, so we're just going to reduce these fractions. And if they're not the same, then they're not. It's not parallel. But if they are the same, then they are parallel. So 16 over 24, both go into 8, so that'd be 2/3. And these both go into 9, so that's also 2/3. So yes, they are parallel because the sides are proportional, and I've showed the work here. And then last one. So you've got this big triangle here. You've got 3 parallel lines. You've got, you're trying to find this x here. So you're trying to find x, m, and a. Okay, so this is a really important question. You're going to see this kind of question show up a lot, where it's going to ask you to set up different proportions depending on what you're given. So let's find x first. So let's do x over 3 equals, how about just 4 over 6? So x over 3 equals 4 over 6, and cross multiply, so 6x equals 12, x is 2. So we know that x is 2. And then let's go ahead and let's figure out what a is. Okay, so to figure out a is one of the parallel lines, so we're going to have to choose the other parallel line to be part of it. So let's do a over 5. Okay, and then equals, and then we're going to have to choose a part of this little triangle. So let's just do 3. So 3 over, and then since 5 is part of the larger triangle, we have to include the entire side length of that larger triangle that corresponds with the 3. So that'd be 3 plus 6 plus 3, which is 12. So that would be one correct equation to set up. You could have also done this side here if you used 2 instead of 3. All right, so I'm going to reduce and then cross multiply. So this is 1 over 4. Cross multiply 4a equals 5, and divide by 4, it gives you 1.25. So 1.25 is your a. And then we can do the same thing to get m. So for m, we could do m over, let's do this side just to switch it up. So m over 6, using this medium triangle, equals 5 over, this entire side is 8. So 5 over 8. Cross multiply, 8m is 30, divide by 8, and you get 3.75. All right, so that is the end of our examples here. Next up, you'll do the Edulastic assignment related to this lesson. Hope you guys have a great day.